Solid aluminum wire was permitted for utilization in 40-amp circuits primarily during the 1960s and 1970s. This practice, however, was later discontinued due to significant safety concerns identified with aluminum wiring, particularly concerning its tendency to cause fires. The prohibition of solid aluminum wire for 40-amp circuits was eventually mandated by the National Electrical Code, or NEC, during the 1970s. The rationale behind the change centers on several factors inherent to aluminum's properties compared to copper, the now preferred material for electrical wiring. Firstly, aluminum possesses a higher coefficient of thermal expansion than copper. This means that aluminum expands and contracts more significantly with temperature fluctuations. In electrical circuits, temperature changes are common due to the cyclical nature of current flow and the inherent resistance within the conductors. When aluminum wire heats up, it expands. If the connections are not adequately tightened or if specialized connectors designed for aluminum are not used, the expansion can lead to loosening of the connections. Upon cooling, the aluminum contracts, further exacerbating the looseness. This loosening creates increased resistance at the connection point. Increased resistance generates more heat, creating a feedback loop that can eventually lead to overheating, arcing, and ultimately a fire. Secondly, aluminum is more prone to oxidation than copper. When aluminum is exposed to air, it forms a layer of aluminum oxide on its surface. This oxide layer is an insulator, meaning it does not conduct electricity well. While a thin layer of oxide is always present, it becomes problematic at connection points. The oxide layer increases the resistance at the connection, again leading to heat buildup. Specialized antioxidant compounds are required to mitigate this effect when using aluminum wire. Thirdly, aluminum is softer and more malleable than copper. This property makes aluminum more susceptible to damage during installation. Over-tightening screws on terminals can easily crush or deform aluminum wire, leading to compromised connections. Furthermore, aluminum is more prone to creep, a phenomenon where the material slowly deforms under constant pressure. This creep can cause connections to loosen over time, even if they were initially properly tightened. Due to these inherent issues, the NEC deems solid aluminum wire unsafe for branch circuits, especially those carrying higher amperage loads such as 40 amps. The transition away from solid aluminum wire involves several key changes. The NEC revised its standards to restrict the use of solid aluminum wire in smaller branch circuits, including those rated for 15, 20, 30, and 40 amps. Instead, the code promoted the use of aluminum alloy wiring, which contains different metals that enhance its strength, reduce its thermal expansion, and improve its corrosion resistance. Alloy wiring is generally safer and more reliable than solid aluminum wire. Secondly, specialized connectors and terminals were developed specifically for use with aluminum wire. These connectors are designed to maintain a secure connection even with the expansion and contraction of aluminum. They often include features such as pressure plates and antioxidant compounds to prevent loosening and corrosion. Thirdly, electricians were educated on the proper techniques for installing aluminum wire. This includes using Torx screwdrivers to ensure proper tightening of connections, applying antioxidant compounds, and avoiding over-tightening. When identifying existing aluminum wiring, several factors should be considered. Homes built in the 1960s and 1970s are more likely to have solid aluminum wiring. Look for markings in the wire insulation that indicate the material. Aluminum wiring is typically marked with the word aluminum or the letters AL. Inspect the connections at outlets, switches, and light fixtures. Look for signs of corrosion, overheating, or loose connections. Common signs of problems include discolored outlets, flickering lights, and warm or buzzing sounds coming from electrical devices. If solid aluminum wiring is present, several mitigation strategies can be employed. One option is to completely rewire the home with copper wire. This is the most expensive option, but it provides the highest level of safety and eliminates the risks associated with aluminum wiring. A second option is to use copper-aluminum pigtailing. This involves connecting short lengths of copper wire to the existing aluminum wires at each connection point. The copper wires are then connected to the outlets, switches, and light fixtures. This method requires the use of specialized connectors that are designed to be compatible with both aluminum and copper wire. These connectors are filled with an antioxidant compound and are designed to maintain a secure connection even with the different expansion rates of the two metals. A third option is to use receptacle replacement. This involves replacing the existing outlets, switches, and light fixtures with those specifically listed for use with aluminum wire. These devices are designed to provide a more secure connection with aluminum wire and often include features such as pressure plates and antioxidant compounds. Regardless of the mitigation strategy chosen, it is essential to have the work performed by a qualified electrician experienced in handling aluminum wiring. An experienced electrician can properly assess the situation, recommend the most appropriate solution, and ensure that the work is performed safely and according to code. Furthermore, regular inspections of aluminum wiring are recommended to identify and address any potential problems early on. These inspections should be performed by a qualified electrician and should include a visual inspection of the wiring, connections, and devices, as well as testing of the connections to ensure they are properly tightened. In summary, while solid aluminum wire was used in 40-amp circuits in the past, its use was eventually banned due to safety concerns. If solid aluminum wiring is present, it is essential to take appropriate steps to mitigate the risks. Consulting with a qualified electrician is crucial to determine the best course of action and ensure the safety of the electrical system. The history of solid aluminum wiring serves as a reminder of the importance of adhering to electrical codes and standards. Codes are updated regularly to reflect new knowledge and best practices, and following these codes is essential for ensuring the safety of electrical installations. Electrical safety is a complex and multifaceted issue. It involves not only the proper selection and installation of wiring and devices, but also the understanding of electrical principles and the recognition of potential hazards. Education and awareness are key to preventing electrical accidents. Homeowners should be educated about the potential risks associated with electrical systems and should be encouraged to take proactive steps to ensure their safety. This includes regular inspections of electrical systems, proper use of electrical devices, and prompt repair of any electrical problems. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It is developed and maintained by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC is widely adopted by state and local governments and serves as the basis for electrical codes in many jurisdictions. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. Adhering to the NEC is essential for ensuring the safety and reliability of electrical systems. It is important for electricians, contractors, and homeowners to stay up to date on the latest version of the NEC and to follow its requirements carefully. Changes to the NEC can have a significant impact on electrical installations, and it is important to understand these changes to ensure that electrical work is performed safely and correctly. For example, the NEC addresses the use of arc fault circuit interrupters, or AFCIs. AFCIs are devices that are designed to detect arc faults, which are a common cause of electrical fires. When an arc fault is detected, the AFCI trips the circuit, cutting off the flow of electricity and preventing a fire. The NEC requires the use of AFCIs in many areas of the home, including bedrooms, living rooms, and dining rooms. AFCIs provide an additional layer of protection against electrical fires and can help to save lives. Another important aspect of electrical safety is grounding. Grounding is the process of connecting electrical circuits and equipment to the earth. This provides a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock. The NEC has specific requirements for grounding electrical systems, and it is important to follow these requirements carefully to ensure that the system is properly grounded. Improper grounding can increase the risk of electrical shock and can also damage electrical equipment. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protection devices such as circuit breakers and fuses are designed to protect electrical circuits from excessive current. When the current exceeds the rating of the circuit breaker or fuse, the device trips, cutting off the flow of electricity and preventing damage to the wiring and equipment. The NEC has specific requirements for overcurrent protection, and it is important to follow these requirements carefully to ensure that the electrical system is properly protected. Using the correct size circuit breaker or fuse for a given circuit is essential for preventing overloads and short circuits. In addition to following the NEC, it is also important to use high-quality electrical products. Low-quality products may not meet safety standards and can increase the risk of electrical hazards. It is important to purchase electrical products from reputable manufacturers and to look for products that are listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL. UL listing indicates that the product has been tested and meets safety standards. When performing electrical work, it is essential to follow safe work practices. This includes energizing circuits before working on them, using appropriate personal protective equipment, and following lockout-tagout procedures to prevent accidental re-energization. It is also important to be aware of the potential hazards associated with electricity and to take steps to avoid them. Working safely with electricity requires knowledge, skill, and attention to detail. Only qualified individuals should perform electrical work. Attempting to perform electrical work without proper training and experience can be dangerous and can increase the risk of electrical shock, fire, and other hazards. If you are not qualified to perform electrical work, it is best to hire a licensed electrician. A licensed electrician has the training, experience, and insurance necessary to perform electrical work safely and correctly. They can also ensure that the work is compliant with the NEC and other applicable codes. In conclusion, the use of solid aluminum wire in 40-amp circuits was a practice that was eventually discontinued due to safety concerns. If you have solid aluminum wiring in your home, it is important to take steps to mitigate the risks. Consulting with a qualified electrician is essential to determine the best course of action and ensure the safety of your electrical system. Electrical safety is a shared responsibility. By following electrical codes and standards, using high-quality products, and following safe work practices, we can all help to prevent electrical accidents and protect ourselves and our families from harm. The information provided here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work.